Alright, so here's a quick video on how you know when you're actually done if you were row reducing a matrix. So if you are doing this process where you're starting out with a system and then, come on, why? This is your answer. So if you're starting out with a system like this, how do you know when you're done, when you're at your answer? So these are the several rules. Anything that's all zeros is below something that isn't all zeros for a row. The first thing in a row that's not a zero is always a 1. Alright, so it's like 1x equals 2 instead of, so it's 1x equals 2 instead of like 2x equals 2 and having to reduce that. And then any two non-zero rows, the one with the 1 most leftwards has to be most topwards. So basically, we'll just go through a few examples here. So you are done when this is okay. So we have every one is going downwards diagonally, and above or below each one is all zeros. Okay, so that is all set. And it doesn't matter whether it equals 0 or a number over here. Alright, all the zeros in one row are at the bottom. That's okay. So yes, yes. This one is actually fine too because the first number of the row is always a 1. Alright, the leftmost one is on the top, right here. And then there's a 2 with zeros under it, but that's alright because this isn't a leading one. These ones here are called leading ones, just because they're the first one in the row. This one's not okay because this row should be on top. Because this is the leftmost one, and it should be at the highest row. Also, this is a leading one, but there is a number above it. That should be a 0. So this should be a 0, and then it would be okay. So for the same reason, this violates it because this should be a 0. Because that's a leading one, so it should have zeros above and below. This doesn't work because this should be a 1, not a 3. Because the first entry in every row has to be a 1. This doesn't work because this should be your top row, and this should be your next row, and this should be your bottom row. Other than that, it would be okay.